All right, let's dive right into this. Welcome to part 1 of our ITGC Master Class. Now, auditing might not sound like an extreme sport, but honestly, if you're a new auditor, a GRC analyst, or working anywhere in IT or finance, you know exactly how high the stakes really are. Over the course of this explainer series, we're going to patiently map out the entire territory of IT audit. We'll go from asking what on earth is an ITGC all the way to sitting down and practically testing real controls, step by step, just like a seasoned auditor would. Think of today's explainer as your map to the territory. Once you understand the foundation we're laying out today, I promise you everything else is just going to effortlessly click into place.
Here is our roadmap for today. Number 1, what is an ITGC? Number 2, why ITGCs matter. Number 3, ITGCs versus application controls. Number 4, the 4 ITGC domains. Number 5, the universal testing approach. And finally, number 6, a quick preview of the series. Let's get to it.
Starting off with Section 1, what is an ITGC? The foundation of trust. So, to truly wrap our heads around IT audit, we've got to start right here. ITGC stands for IT General Controls. By definition, these are the foundational controls over an organization's entire IT environment that keep the systems processing your financial and operational data reliable, secure, and trustworthy. Think of it kind of like the concrete foundation and plumbing of a house. You don't usually walk into a home and say, wow, look at that gorgeous concrete foundation. But if that foundation is cracked, every single room built above it is at risk of collapsing. ITGCs are literally that foundation. If the IT environment is well controlled, auditors can sleep at night knowing they can trust the data inside the applications. But if that foundation is weak, no way. We can't trust anything the system spits out because someone could have silently changed the data without anyone ever noticing.
Which brings us to Section 2, why ITGCs matter, the pervasive ripple effect.
Let's move from the theory to the actual real-world stakes. Why do we care so much? Well, the crucial point is that ITGCs are what we call pervasive controls, meaning a single failure here creates a massive ripple effect. First up, they're absolutely required for financial statement reliability under SOX and ICFR. Second, both external and internal auditors plan their entire audit around ITGCs. If these controls are rock solid, auditors can rely on the system and actually do a lot less manual work. But if they're weak, that reliance collapses and auditors are forced to manually verify massive amounts of data. And beyond just the audit, strong ITGCs are what provide your everyday security, prevent fraud, and keep you compliant with really strict privacy laws and industry standards.
Okay, let's quickly decode some alphabet soup because you're going to hear these acronyms constantly. SOX is the Sarbanes-Oxley Act. That's a U.S. law requiring public companies to actually prove their internal controls work. ICFR stands for Internal Control over Financial Reporting. That's a specific framework used to prove those financial numbers are actually accurate. Now, most of this financial data runs through an ERP, or Enterprise Resource Planning System. Just think of this as a massive, integrated software application handling everything: finance, HR, operations, the whole shebang. Finally, IAM is Identity and Access Management. Those are the systems and processes ensuring only the right people can actually get into that ERP. Because your financial processes are living inside the ERP, testing your ITGCs is a strict, non-negotiable requirement under SOX and ICFR.
Moving right along to Section 3, ITGCs versus application controls, knowing the difference.
Before we look at the specific domains, we really need to clear up what is probably the most common beginner confusion in IT audit: the difference between general controls and specific transaction controls. ITGCs, the general controls, apply universally across the entire IT environment. So, for example, a rule that says only authorized people can change program code is an ITGC. Application controls, on the flip side, are built directly into a very specific business process or transaction. A classic example here is a three-way match in a generic ERP. The system will automatically block an invoice from being paid unless the invoice quantity perfectly matches the purchase order and the receiving document. It's a great control, but here is the massive dependency narrative you need to remember. That brilliant three-way match application control is utterly untrustworthy if your general change management ITGC is so weak that a rogue developer could just silently go in and switch the match off. Make sense?
Let's look at how this builds in Section 4, the 4 ITGC domains, the core framework.
Almost every standard IT control framework out there categorizes general controls into 4 universally accepted domains. They act as a complete safety net for your systems. And here's a super simple 4-part memory aid to help you effortlessly categorize them. First is access, who gets in. Second is change, what gets changed. Third is development, how new things are built. And fourth is operations, how the system keeps running day to day. We're going to methodically walk through each one of these right now.
All right, domain 1 is access to programs and data. You'll often hear this called logical security. The core idea here is really simple. The right people have the right access, and only the right people. Because if this fails, the risk is incredibly severe. Unauthorized people can view or change financial data, and that leads straight to fraud, costly errors, or massive data breaches. To prevent that nightmare, an auditor focuses heavily on how access is originally approved, checking password policies, and ensuring that regular user access reviews are actually being completed by management.
Now, a critical part of this access domain is SOD, which stands for segregation of duties. This just ensures no single person controls conflicting steps in a critical process. Let's use a grounded, generic ERP example. A finance clerk should absolutely never have the access rights to both create a new vendor in the system and then independently approve a payment to that exact same vendor. Because if they can do both, what's stopping them from setting up a fake company and just paying themselves? As it turns out, auditors highly frowned upon that. SOD controls physically prevent that combination from existing in the system.
Access controls are managed through what we call the JML lifecycle. That's joiner, mover, leaver. Joiner is when new access is provisioned for a brand new hire. Mover is modifying that access when someone gets a promotion or changes roles. And leaver is the prompt termination of access when someone quits or is fired. Let me be crystal clear here. Leaver controls are one of the absolute most rigorously tested areas by auditors. If a disgruntled employee is fired, but their ERP access isn't removed immediately, the risk to the organization is just astronomical.
Let's move on to Domain 2, which is change management. The idea here is that any change to a system's code or its configuration has to be formally requested, tested, approved, and then carefully moved into production. The big risk of failure here is that an unchecked change breaks the system totally silently. Imagine a developer pushing malicious or even just accidentally flawed code that alters how tax is calculated across your entire generic ERP. Every single invoice would be wrong, and nobody would know. So auditors focus on tracing ticketing logs to ensure the person who wrote the code is strictly separated from the person who actually deployed it.
Now, what's really interesting about this slide is the concept of UAT, or user acceptance testing. This acts as the absolute essential business safety net before any major code change is deployed to production. See, the developers might think the code works perfectly, but UAT requires actual business end users, like the folks on the finance team, to test the change in a safe sandbox environment and formally sign off that yes, it behaves correctly for their daily operations.
Domain 3 is program development. Now, while change management handles those routine day-to-day updates, program development focuses on massive, brand new system implementations. The huge risk here is going live with a totally broken system, missing controls or corrupted data. For example, if you're migrating an entire company to a brand new accounting system, auditors are going to focus heavily on data migration reconciliations. They want to make absolutely sure that the opening balances in the new system perfectly match the closing balances of the old system before anyone pushes that Go Live button.
To keep that from becoming a disaster, these massive projects are governed by the SDLC, the System Development Lifecycle. This is a highly structured, multi-phase process for planning, creating, testing, and deploying an information system. Auditors verified that this rigorous framework was followed from day one. Honestly, the SDLC is what ensures that a multi-million-dollar, company-wide IT project doesn't just instantly destroy the integrity of a company's financial reporting on launch day.
And finally, Domain 4 is computer operations. Once the system is built and the access is locked down, it still has to run reliably every single day. The big risk here is data loss or silent failures. For instance, if a scheduled overnight job that posts subledger entries to the general ledger just fails in your ERP and no one is monitoring it, well, your financial data the next morning is silently incomplete. Auditors will meticulously check job scheduling logs, monitor incident tickets, and verify that system backups are not just taken, but actually successfully tested for restoration.
Moving right along to Section 5, the Universal Testing Approach, how auditors actually work.
So now that we understand the theory of the 4 domains, let's transition into the practical, step-by-step reality of how an auditor actually executes their work. It's pretty cool because no matter which domain you're looking at, the testing rhythm is always the exact same. Step 1, understand the control by reading the policy and talking to the owner. Step 2, test of design. Step 3,
test of operating effectiveness, and step 4, conclude and report on your findings. Seriously, keep this precise 4-beat rhythm in your head, because I guarantee you, this exact sequence is going to be the backbone of every single future testing explainer in our series.
And this brilliantly illustrates the core logic of auditing. TOD versus TOE. Test of design, or TOD, always comes first. It uses a walkthrough of just a single item to see if the control's logic is actually sound on paper. Test of operating effectiveness, or TOE, comes second. That uses statistical sampling across the entire year to prove the control actually worked consistently in practice. Now, if a control fails its test of design, meaning it's poorly designed on paper, auditors won't even bother with the test of operating effectiveness. Why? Because it's literally impossible for a badly designed control to be effective in practice. And finally, Section 6, Series Preview, Looking Ahead.
Wow, we have covered a lot of ground today, haven't we? From the foundation metaphor to the 4 domains, all the way to that TOD and TOE testing rhythm. But remember, this overview was just the map. Coming up in the ITGC Master Class, we're going to transition from theory to hands-on reality. In Part 2, we'll do a massive deep dive into access to programs and data. Then, in Part 3, we'll do practical, over-the-shoulder testing of user deprovisioning, that critical lever process where we'll look at real evidence and apply that TOD and TOE rhythm. Future installments will take us hands-on through change management, SDLC, and operations.
I want to leave you with this thought. We called ITGCs the foundation of your systems. Think about your own organization for a second. If your system's foundation cracked tonight, say an administrator's access was compromised, or a developer silently altered your financial logic, would your controls detect it before the entire